So hi everyone, so I'm Rohit. I am co-founder and VP engineering at facets.cloud. So today the talk is more about platform engineering and how you can bake in the zero trust philosophy into your platform, right? So that should be the takeaway that you should be looking for, not the specifics of the implementation itself. And specifically, we apply never trust, always verify philosophy into every component that goes into the platform, right? So this is a customer's journey. So this is a customer in the fintech domain. In fintech, in modern times, it is a balancing act, right? Like you have to balance between agility, that is launch new products for new geographies, new partners, right? And at the same time, you have to comply with a lot of standards and for a good reason as well. So it's not like a burden, it is there for a reason. All of these compliances, whether it is PCI DSS, RBI, cybersecurity guidelines, these are there for a purpose. Now, how do you balance these? This is exactly what our customer, who is a tech-first fintech company, who often launches new products across different geographies, different partners. And also, their team is very uniquely agile. They would like to prototype and fail fast. And at the same time, they are also a heavy adopter of CNCF projects like Kubernetes, Istio, things like that. Now, you see where this is going. So they have a very agile development team who wants to experiment, who wants to put things out into the market, while they also have to comply to several standards. So this is exactly where they hit a turning point. So, I mean, around about 2023, they had a bunch of products that were lined up. They had automations, but their automations were project specific. So they were playing catch up in terms of automating and ensuring security in each of those product lines. And the compliance requirements just before launch. So this is the worst part of it, or I don't know what, that you have to comply to everything even before you put your first proof of value product out there, right? So that was looking daunting in terms of the timeline. And this is where everybody came together for the idea of a platform, right? Development teams were of the opinion that, hey, I need more agility, I want a platform. Security teams were clamoring that, hey, I need guarantees out of the box, right? I don't want it done different way in different projects and, some people ahead, some people lagging behind. So which is why they built the internal developer platform. So what the platform, so this is general summary of the platform. So the platform engineers would create small reusable components like an EKS module or a module for a microservice, a MySQL module, things like that. So these are reusable modules that you create and publish to the platform. And it is built in such a way that they slot in together very well, very nicely, right? Like, so developers can just go to the portal and compose a blueprint of your product using the automations that are there. So the good part is, platform engineers can abstract away a lot of the implementation complexity away from developers, and developers get all the freedom that they want, and they should have, right? And exclusively that. And then once, so you can imagine what the developers build as sort of CRDs or inputs to Terraform module sort of things declared in a Git repository. And there is an automated pipeline that takes care of executing these automations for them. So this pipeline is essentially a GitOps pipeline that would look at the source of truth that has been composed by the developer, and it would apply it to the target environment, but with an extensive policy validation framework. So this is something that would become a highlight of this whole solution. So which is why I would just go into the validation engine itself. So this is an example. So let's say there is an IAC plan that is getting generated as a part of the deployment. It goes into the validation engine, and there is some policies defined in policy as code in a repository, right? Now, the policy engine generates a tri-stated acceptance criteria there, which is either it is accepted, it's all good to go, it looks safe. The second is a special one where it needs approval, or it needs a second set of eyeballs to go look at whether the change is good to go or not. And the third is outright rejected, right? So these are the, so as when you write policy as code, these are the three different options that you can define over there. Now coming to the specific use case, so while applying the platform principles, what happened is securing east-west service communication is a compliance requirement. Now we'll see how, with this example, we'll see how zero trust was baked into the platform itself. So what is east-west communication? So it is service-to-service communication within your cluster. In this specific case, it is Kubernetes cluster. It is chatty microservices. So we felt that this is riddled with trust. So trust is a bad thing in the tech world. So what happens is services talk to each other freely. Everybody is allowed to talk to everybody is the usual posture. And the internal traffic is often unencrypted. They would suggest that, hey, it's all happening in my VPC, what's the harm? And there is no identity validation as to who called which service and was he allowed to, right? This is never a concern. And this should be a concern because there are several overlooked risks over here. So one is your workload is vulnerable, you have some outdated packages over there, or there is a supply chain attack that has compromised your microservice itself. And this would rather, this whole approach would laterally expand your attack surface, right? Like one microservice is compromised, you're exposing the data via all of the other microservices. So this is why I'll focus on this particular use case and how it was solved, right? So of course, I'm sure like most of the people in this room know what the solution is. It is to apply Istio. So for the uninitiated, it is basically a service mesh, right? It has the ability to encrypt your internal traffic as well as attach identity to it using mTLS. We'll see how. And it is identity aware. So you can assign workload A an identity and workload B another identity and make sure that workload A is allowed to call workload B or no, or with fine-grained permissions, right? And this fine-grained part is why Istio becomes the default choice. So I'm sure Kubernetes, everybody knows that there is network policies, and why do I need to write these, right? So oftentimes it's not just a white and black decision. It's often gray, like it is allowed to call, but only the get operations, right? It is allowed to call, but only within certain constraints or certain endpoints. So which is why you would employ Istio, so that you get very fine-grained controls on the service communications. So I'll first touch upon mTLS. So mTLS is mutual TLS. So essentially what Istio, maybe I'll touch upon on how Istio works. So Istio injects a sidecar an Envoy proxy to all of your workloads, and all of the traffic goes via that. Now the Envoy proxy talks to a central control plane, fetches all the policies, all the restrictions, and then applies to the traffic, right? So that's it's an Envoy proxy layer that does all the magic there. Now, when you enable mTLS in a mesh, what happens is that the Envoy proxy creates a gets a certificate that is assigned to its workload, identified by the service account, the Kubernetes service account, and the certificate is assigned to it, and you also get a private key that is unique for your workload. Now, when you communicate to from one service to the other, you don't need to do anything in your application code. The traffic is automatically encrypted, and the receiver can verify that the request has originated from whoever he claims to be, and vice versa, right? So using the certificate. So all of these certificates are generated from a common mesh level root CA. So which is why they can verify the identity of the caller, and these are bound to the service account of the workload, the Kubernetes service account of the workload. So this ensures that the traffic is encrypted, and there is a strong identity binding, and and Istio provides a way with which you can enforce this by default, right? So yeah, so this is a nice illustration of what it does. So if Eve claims to be Alice, Bob can clearly figure that out. And Alice and Bob, if they're allowed, they can communicate freely with each other, right? This is what mTLS assigns, and basically the ability to attach an identity to requests is coming out of the box. So how do you, there is just a CRD called peer authentication, and you just set it to strict by default. Your complete mesh is locked down, right? So this is as simple as that, just a kubectl apply away. You can enable mTLS and make sure that you are now at least encrypting all of your traffic and attaching identity to all of the requests that are happening within the cluster. Now comes Istio authorization policies, right? So this is where you define who can call whom, right? And you can, so as I mentioned earlier, there is very fine-grained control that you can have. You can define which identity is allowed to call which service based on their path, the HTTP methods that are allowed, ports, things like that. And this is declarative. That of course goes without saying nowadays, that it is declarative. You can write a YAML for the policy and apply it, and it will apply. So let's see an example of how this would work out. So workload A, when it tries to communicate to workload B, it goes via the proxy, and it fetches the authorization policies over from the control plane and verifies that it is allowed to make the call, or and it would prevent the call from even originating in the first place, right? Now, how do you enforce this cluster-wide again? So by default, you would want, especially in fintech and highly regulated industries, you would want it to be deny all by default, right? Like you don't want any traffic between microservices unless explicitly authorized. So you would create an authorization policy. So this is an authorization policy without any specification. So it applies to anything and everything. And you are not explicitly allowing traffic. So it would by default deny anything, right? So you just create the CRD and apply. It is all good. Now, how do you allow services to communicate with each other? So let's say there is a application that is core banking API, and you want to define who is allowed to call it. So you would specifically mention the service accounts. So loan eligibility service is allowed to do get operations on the accounts from the core banking API, right? There is another service, the KYC service, is allowed to make post calls to verify the customers whose KYC has happened, right? And there is a payment service that that can make get and post of the transactions of the user, right? So this way you can fine-grained regulate what APIs should be made available to even the other microservices. Now comes, so I've talked about all the tooling, Istio, it's very standard, all of these things are out there. Now, how do you bake in as a guarantee into your platform, right? So as I mentioned earlier, so modules abstract Istio away. So implementation detail, Istio is an implementation detail. So the platform should abstract it away from the developers. It should be made as developer friendly, right? Like if you saw the YAML over there, it talks about service accounts. If you expect developers to go write the service accounts over there, that's an overhead for them. They have to go figure out what that other service account is and then come fill it over here, or vice versa. That if I have to whitelist my service with another one, I'll have to identify the service account, go and put it over there, right? So I don't want all of that and over that overhead. Make it as simple as possible for the developer. That is the first aim. And policy enforcement should ensure that never trust and always verify, right? And so the validation engine has the responsibility now to never trust anything, including your own implementation, right? You have to have zero trust even on your implementation and have an independent validation engine that can verify all of this. And you would need central control. So if you want to upgrade a component or change the mechanism of operation, you should be free to do so without asking 100 developers to change the YAMLs. So now we'll talk specifically about two different modules that are part of this building block. So the building block for Kubernetes cluster and the building block for microservice. We'll talk about both of these. So first I'll talk about the building block that platform engineers created for the Kubernetes cluster module. So it bundles Istio by default, right? So this is a requirement for whoever is writing whichever platform engineer is responsible for writing and maintaining the Kubernetes module, he has to bundle Istio with any cluster that he creates. It should have a deny all authorization policy, the YAML that I showed you, and peer authentication configured so that mTLS is on by default, right? So this is a requirement from any Terraform module or whatever module, like if you're using cluster API, you have to make sure that cluster API bundles with it these extra workloads, right? Now, the policy validations that you need on top of it is that any plan that gets generated ensures that the Istio deployment is there is a deny all policy, and there is this peer authentication CRD. Any plan that deletes any of these components is outright rejected. So if you remember from the tri-stated way, so any plan that gets generated to remove any of these components should outright be rejected, right? So even by accident, it should never happen. So this is like a validation policy to prevent and to make sure that the deny all authorization policy already exists, right? So it detects so in this particular case, the implementation is Tofu or Terraform underneath. It applies to any other automation framework, but the advantage of having something like a Terraform or Tofu in this particular use case is that it generates a plan file before you actually apply it, and you can apply your policies on that plan file, right? Unlike, let's say, an operator where you apply it and wait and watch. So that is the beauty of the Terraform part. Not a big fan, but still this is some part where it comes of use. And some DevOps are fluent in it, right? So EKS cluster. So whenever an EKS cluster is created, it also makes sure that there is a deny all Kubernetes manifest that is getting created, right? So this is standard Rego code that the security team maintains and ensures that the cluster always has the deny all policy. Similarly for peer authentication. So whenever a cluster is created, there is an enforcement that the peer authentication that enforces mTLS is present. Now, coming to the microservice module or the workload module that developers usually interact with, where they add microservices or whitelist other microservices that are allowed to call it, right? So it makes sure that the Istio sidecar is always injected to the workload. So this is baked into the module itself. It would take a whitelist of services. So just the whitelist of services with what it is allowed to do, what not. And the module would generate the underlying authorization policy for you, right? The Istio authorization policy that is needed. The module would take care of doing it. Now again, what are the policy validations that you need here? Any whitelist change would halt the pipeline for an approval. So if from the tri-stated states that it can go to, if there is any change to an authorization policy, it would always go into a pending approval state. You need a second set of folks who need to come and verify that this is good to go, and then it can go, and approvers are notified. And of course, there are some standard policy validations that are required, like enforcing Istio sidecar, things like that has to be always present. Now, I'll show you an example of, I should have mentioned this earlier. So when a developer defines a workload, he also gets a UI to do so, like that is automatically generated from the module's input schema. A form gets automatically generated. So this is what a developer would work with, right? He can work directly on the YAML, or he can come to the UI and do it. So in this particular case, he has like 3 services that are already whitelisted. He gets to mention what path and what methods are allowed, right? And he gets a context-specific drop-down of what are the microservices that are there in the project, right? It's not like some string that needs validation later or is prone to failure. So this way you can preempt any failures or any mistakes that a developer could perform and make his life easier as well in the process. Yeah, so now similarly, so just like we had auth policy for the Kubernetes cluster, validation policy for the Kubernetes cluster, you have some Rego code defining that authorization policy, that any updates to the authorization policy would go into needs approval state automatically, right? So this is not a facility that is present within Rego. So this has been done by convention using the messages that come out of Rego policy evaluation. So now, when the pipeline runs, right? So this is an example of when the pipeline runs. So if you see here, so it says that, hey, a modification of an authorization policy payments is found and it needs approval, right? And the pipeline halts over there. So this can be implemented. This is in our pipeline implementation in GitHub Actions. Anywhere you can do some sort of wait for approval or wait for a human input sort of thing, and it would go into a pending approval state, and somebody with authority has to review the plan and approve it to go forward or reject it, right? So now that we have created some policies that can secure your cluster by default and also the workload by default, the next point that comes to is securing the Istio control plane itself. So we would have locked down the Istio namespace completely only for the pipeline service account and break glass service accounts. Only they are allowed to make any changes in the Istio system namespace by default. Now, Istio CRD creation. So like think of it this way, that what if in your pipeline you allow deploying some arbitrary Helm charts, and there is some authorization policy coming over from there that is conflicting with what you have built, right? That could be a supply chain attack of its own. Now, how do you prevent that? So the platform itself has a platform-wide policy that any plan that introduces an authorization policy or peer authentication needs to come from these 2 modules for which extensive set of validations are present. Anything else is outright rejected. You're not allowed to do that. And that gives the security team the guarantees that, hey, these are the only sources from which the policy changes are flowing in, and they have been audited and approved. And they have a full trail of it. So we also allow exporting these pipeline runs by the resources that got modified. So you can make a query that, hey, give me all of the modifications to authorization policy in this cluster. And the pipeline would, so there is a query interface or pipeline that can query it and retrieve that information for you. So now for audits and things like that, you have a complete trail of who made what change, why, and whose approval was there, right? So this becomes crucial for compliance requirements, things like that. Now, coming to the next question, so is this really zero trust, right? So it's not, right? That's the simple answer here. You are trusting the policy engine. You're trusting Istio itself, the policies itself, right? Whenever we say zero trust, it's never zero trust. But what you're trying to do is you're trying to minimize the surface area of the trust that you're applying, right? So in this particular case, so I would say we have covered preemptively any trust that we have placed using policies, validations. Now, anything else that you trust on, you would proactively have to keep on monitoring. Say, for example, Istio, right? So when I mentioned Kubernetes cluster module, there is one thing I forgot to mention, which is that it always deploys a service, a stub service inside it called service monitoring and service monitoring target. And service monitoring target has an explicit deny to make certain API calls on the service monitoring target. Now, what happens is, if in case service A is somehow able to make those calls that he's not allowed to, it would trigger an alert and also fail a health check on the load balancer, on the central load balancer. So what this makes sure is that the moment if there is even an issue in Istio, like let's say there has been a supply chain attack on the Helm chart that we've used to deploy Istio, and somebody has compromised it and authorization policies are no longer working as expected, we call it the canary testing suite, figures it out and pulls the plug on your service, right? So even for a moment, if you think your trusts are misplaced, you should bake in some sort of a fuse, right? And yeah, so as I said, so the trust that we have employed is limited and explicit, and this is fully auditable and regularly reviewed. Yeah, so this is another thing that happens. So there is another service whose purpose is to query metrics and make sure that if service A has some authorization policies allowing service B, and it notices that there has been zero traffic over the last X weeks, it would just trigger an alert and automatically raise a pull request removing that service from there, right? So again, you are being forced to explicitly say that, hey, maybe in the last 3 weeks it's not been used, but it would come up again, right? So this sort of feedback loop is also baked in, because again, this is a question that will come from the auditors. Hey, give me proof that you are validating your authorization policies regularly. How do you even give that? Like, most people just show a ticket that was created and somebody comments that all looks good and give a screenshot. But this is a systematic platform way of doing things. So what did we achieve? All the traffic is encrypted and authorized. Developers are unaware of the complexity of the service mesh. The platform becomes a compliance accelerator, and this is of value when you actually want to comply, right? And not just pass through some certifications, and you actually want to comply. Your platform should enable and make sure of these things. Now, what are the takeaways for you guys? So I don't want to focus on Istio or the Kubernetes or the implementation in general, but try and figure out from our sort of exercise how we try to isolate where are the trust placed. The trusts are placed in the module that is implemented. The trusts are placed on Istio, right? So basically audit it and try and minimize it. And automate, but verify with policy always. And this is something that I can't re-emphasize over and over again. And there is, which is also one of the reasons why we stick to things like Terraform, where I can create a structured plan before I apply and pre-fact validate things. And I would like to see that come up in more automation platforms like Crossplane. Maybe give me a way to have a dry run and export some sort of a declarative structure that I can validate on top of. Now, this also makes security invisible to devs, but easy to verify. And this is extremely important, and you need to try and figure out how you can make your audit reports automated, right? Like try and export modifications, alterations, or proofs from your platform rather than try and collect it post-fact. Yeah, so that's pretty much my talk. Open to questions now. Thanks, guys.
So the folks who have questions, the mic is waiting your presence.
Hey, okay. I understand that we have configured a lot of policies at the Istio control plane, if I'm not wrong, since it manages all the certificates. But being, used for fintech platforms, right? So how are we ensuring that we have minimal latency? Because adding policies, they involve a lot of CPU and memory overheads, right?
Right.
I mean, in a couple of places at least.
Right. So I think you got me wrong there. So the policies are enforced before the policies are applied into a cluster when the plan is generated. So it is in the Git pipeline, the delivery pipeline, in between that this validation. So validations itself does not incur a latency tax. But yes, Istio itself is doing some evaluations as to do. But these things are very minimal. So if you see envoy proxy fetches the policies, and then all of those processing can happen in the envoy proxy in a very minimal time, and they keep improving it. So it's not like there is a go around from the control plane every time a request originates. So that's not the case. And oftentimes nowadays what happens is people are all into gRPC. I gave a RESTful example, but people are on gRPC. So once the session is established and the functions are going, the evaluations are just minimized to what path it is calling, right? Like essentially which function. So there also you try to introduce a mesh without paying a lot of penalty for latency. And these fintechs that we work with, or this particular company, are like value adds that you build on top of banking platforms, not exactly the financial.